All right, so we're going to look at linear scheduling method here. It's a different way of representing a schedule. This actually works pretty well with start to start type of activities or activities where you may have some kind of buffer. In this scenario, I have a project that consists of 5 activities. I apologize for the font. It's as big as I can make it without really blowing off the page. The 5 activities are: A is excavating a trench, B is laying a subbase of gravel, C is laying a concrete pipe, D is backfilling, and E is compacting. So these are all actually a natural sequence of activities. They just have different rates of productivity. So what you're to assume here is that the project is 1,000 feet in length, so it's a linear construction project, and that the productivity rates of the 5 activities are 400, 100, 250, 125, and 200 linear feet per day, respectively. If per day, draw the project diagram using the linear scheduling method, leaving a minimum 2-day buffer. Okay, so let me show you how to do this. I have to represent the location vertically right here. So since we actually just decided that it was 1,000 feet, I'm going to multiply these by, or actually just do this in increments of 100. So I'm going to go up 10 squares here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to mark that as 1,000. So this would be 900. This would be 800, 700, 600, 500, 400, 300, 200, 100, and of course 0. Okay, so the way I do a linear scheduling method, actually I'm going to cap that off right there so maybe it's a little bit clearer for everybody to see. This is when the project would be complete, or actually when each task would be complete at this line right here, so I can use that as my reference guide. The first activity is excavating a trench, and I can do that at a rate of 400 linear feet per day. So if I've got 1,000 feet and I can do that at 400 feet a day, that takes me 2.5 days. Now, the tricky thing about linear scheduling method is that you're going to use decimals. And for testing purposes, I would rather you round up than round down, regardless of the number, because if it exceeds a day, obviously that's going to branch into the next day. You can do 2.5. You still have to maintain this 2-day buffer. So if you want to do the decimals, you can, but it gets a little trickier that way. So instead of doing a 2.5, I'm going to round up to 3. So this is day 3 right here. And I'm just going to draw a line between the very beginning of the project, which actually the beginning of the project in linear scheduling method starts right here down on the bottom left, and that first line. So that right there is activity A. And really what you're looking at is a rate of progress over time. So times this way, this is how much of the thing you've got completed. Activity B is laying a subbase of gravel, and I can do that at a rate of 100 square feet, or excuse me, linear feet per day, meaning that it will take me 10 days to complete that project, right? I need a 2-day buffer in between. So at no point can I put the trajectory of this line any closer to 2 days. If I put that 2-day up here, it's a much slower rate of progress, and the line's going to go off the chart. So I'm actually going to count my 2 days from here, okay, and start there. And really what I need is, if this task takes 10 days, I need to count this way, 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Line may get a little confusing right here. We've got 1, 2 right here. I hope I left myself enough room. Okay, so the important thing to remember here is that I've got that 2-day buffer intact, okay? I can't put that 2-day buffer up here because this rate of progress is much slower, meaning that the start date for that would have crossed over this line. I don't ever want to cross over that line. So the next scenario, or the next activity, laying a concrete pipe, I can do that at a rate of 250 linear feet per day, which means it only takes me 4 days, right? So I have to decide whether the 2-day buffer is down here or if it's up here. If I put it down here, and actually I should just track this for you guys to give you an example of what not to do. 1, 2, 3, 4. That would be up here. Hold on. 1, 2, 3, 4. Did I put it on the wrong sync? That's a 2-day buffer right there. 1, 2, 3, 4. So it's actually up here. So what happens here is if I just write a faint dashed line, it would cross over the other line. And in reality, what that means is that if I started laying concrete pipe 2 days after the start of laying a subbase of gravel, I would catch up with the other trade after about 300 linear feet. And then I'd just be kind of butting into the back end of it. Okay, so because I have a slower rate of progress on the predecessor than I do on the successor, the 2-day buffer goes up here. So if I put that 2-day buffer up here and count 4 days backwards, I still maintain the 2-day buffer, and then nobody's bumping in the back of one another. So that goes down here, 1, 2, 3, 4. I still maintain my constraint and maintain my 2-day buffer. So that's activity C. Sorry, I'm not labeling these right now. That's B. That's C. Activity D takes 8 days, so 125 linear feet per day. It's 1,000 linear feet. That makes it an 8-day duration. So I can't put the buffer on this side because if I do an 8-day duration, if I can't count backwards from here 8 days, I'm going to cross over. So the buffer is going to come from here down the bottom. I'm going to count out 1, 2, 3, 4, 5, 6, 7, 8. And I'm starting to worry now if I've left myself enough room. So 1, 2, the buffer, 1, 2-day buffer. This is activity D. Okay. And then the last one, I have a 200, what am I doing for the last one? I'm compacting, and I can do that at a rate of 200 linear feet per day. It's going to take me 5 days to do that. If I start on this end and count out 5 days this way, my lines are going to intersect, right? So I can't do that because it's a faster rate of progress. So actually the 2-day buffer is going to come out here, and I'm going to count backwards 5 days. So 1, 2, 3, 4, 5. It's this one right here. And there I have activity E. So the thing that's actually pretty cool about linear scheduling method is I can kind of get a visual representation of the rates of progress. I can also calculate with linear scheduling method the number of days. So if I come out here, this is my final day. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22 days. I know that that schedule takes actually just 22 days based on the fact that I've maintained a 2-day buffer in between each of these, okay? And depending on whether the rate of progress is faster or slower, if it's slower, I'm probably going to start on the bottom side. If the subsequent rate of progress is faster, I'm going to put that buffer on the other side. If I don't do that, then the lines intersect, okay? One other thing I would mention to you is the first one where I got a decimal point, I got 2.5 right there. I did round up. So if you're looking for an explanation as to why that one's ended up on 3, it's because I just rounded up. And some of these other examples, they do round up. Others I don't mind. As long as you maintain that 2-day buffer, I think you will have done things correctly whether you round up or not.